Assalamualaikum dan salam sejahtera. My name is Nurhaja Atila binti Nasir. Today I will present my final year project entitled Inventory Management Using Economic Order Quantity EOQ Model via Analytical Hierarchy Process Method and Analytical Network Process Method. For the introduction, management of inventory is one of the important elements in industry due to the direct impact on the cost and the profit. The order quantity of spare part is unspecific due to the irregular demand of part. Some part have great demand, some part have less, which lead to the difficulties in ordering and managing the inventory. So the objective is to analyze and select the best combination of material and supplier of welding tips to utilize the analytical hierarchy process (AHP) and analytical network process (ANP) tools to evaluate the best option of material and suppliers. To generate the economic order quantity EOQ model to produce an optimal spare part quantity order. The scope for these studies is the type of welding tip used for this project is welding tips type A only for RFID contactless smart card product. Material used for the welding tip is tungsten metal SDW02 only. The multi-criteria decision-making analysis will be limited to traditional AHP, triangular fuzzy AHP, traditional ANP, triangular fuzzy ANP. The inventory management supply chain management system increases the competitive between suppliers as the system needs to utilize the best practice in the manufacturing company. MCDM allow the most reasonable criteria individually or a combination to be ranked strategically. In solving the MCDM situation, many methodologies have been constructed. The purpose of ANP in inventory management because of few factors, which is several criteria and alternatives can be evaluated, consideration of both objective and subjective factors, various interaction between supplier selection criteria and the alternative. For the in-basic AHP technique, the criteria analysis is limited to crisp number during the scaling pair correlation among the criteria. AHP technique does not compute the uncertainty that is related with the mapping decision maker to produce a number. Fuzzy logic was brought in the AHP for the MCDM to cater the uncertainty of human judgment and replicate the human thinking. For the AHP, we use the SAT scale. For the fuzzy logic, we use the fuzzy triangular values. For the methodology, start with research problem formation, literature research, industry data collection from journal by Chiron 2019, data analysis, traditional AHP, triangular fuzzy AHP, traditional ANP, triangular fuzzy ANP, and then I do the consistent result analysis on EOQ, result analysis and optimization, and then conclusion. For the hierarchy, there is 4 levels, which is level 1 target or goal, criteria, level 2 subcriteria, level 3 alternative, level 4. For result and discussion, from data from the journal, I do, for example, productivity data. There is bond count, and then from the bond count, I will be ranking the productivity data. After do the ranking, I will do the comparison of the productivity respect to alternative, which is option 1 until 8, option 1 until 8. After I got the summation, I will do the vectors of priorities using the formula. Getting the vector of priorities, after getting the vector of priorities, I need to check the consistency ratio. The consistency ratio must be below 0.1 to ensure the comparison is consistent and calculate correctly. Then I will repeat the step 1 until 5 for all criteria and subcriteria. This is summary of weight for the AHP. Then I do the normalized weight. To normalize the weightage, multiply the first level sub-criteria with alternative. Final weightage is to multiply the main criteria with the PV with all alternative normalized weightage. And I will get the ranking of alternative which overall priority. The best one is option 8. For the triangular fuzzy AHP, from comparison of AHP, I convert to the triangular fuzzy AHP using the fuzzy triangular value, and then calculate the geometric means of user comparison value for L, M, and U. Then I do the summation of fuzzy comparison value. Then I calculate the fuzzy weight by summation of column to the power of -1, and fuzzy weight. After I normalize the of diffusified weight N1, I repeat for all subcriteria. Then I will get the summary of PV. After that, do the normalized weight and final weightage. Follow the method used for traditional AHP. The final weightage is shown, and the best option is option A. For the traditional ANP process, this method will utilize AHP method. The step is different when finding overall ranking. The priority vector calculated in previous traditional AHP will be transferred into supermetric. This is the formula for the supermetric. And then for the supermetric, for the supermetric, I will do the limiting matrix by multiplying the supermetric with its own value. Then I will get the overall priority. I use Octave software to do the multiplication of supermetric. For the triangular fuzzy ANP, I use method utilize the triangular fuzzy AHP method. This step is different when finding the overall ranking. The priority vector calculated in previous triangular fuzzy AHP will be transferred into ANP supermetric. After the performing supermetric, I will do the limiting metric using the octave. So there is a final overall priorities. The result for 4 MCDM is traditional HP. Based on the result obtained from the four method, option A is selected to be optimized using EOQ. For the optimization using EOQ, there is using the formula 2dB over C, which is annual product, annual wedding tips used, holding cost, and then C is holding cost. After that, I will got the information. The EOQ value is 89 pieces. The minimum is 11 pieces. Quantity of wedding tips ordered through 1 year period is 522. The ordering is split into 6 cycles as EOQ suggested 87 pieces at single period. Purchasing of new inventory must be done when quantity of inventory reduced to 70 pieces. As the conclusion, based on the result obtained from the 3 MCDM method, option 8 is selected to be optimized using EOQ. From the comparison, the traditional AHP and traditional ANP, the two methods have same value for final weightage. While comparison between triangular fuzzy AHP and triangular fuzzy ANP will result to the same final weightage. The best combination of material and supplier is fabricator HID and material supplier is Plan C. From the option selected, optimization of EOQ will result to reorder point, reorder quantity. This company will know when is the right time to make purchasing cost, and inventory holding cost. This will result a better inventory management and material flow in manufacturing company. Thank you.